Alright, so in this lesson, I'm just going to go through some algebraic fractions. We, in the last class, went through a really tough one, didn't we? We went through pretty much the hardest one you could do. So it only gets easier from here. But first of all, we could be asked to find an expression for the perimeter and area of each of these shapes. Now, let's have a look at this shape here. If I wanted to find the perimeter of this shape, then I need to add, of course, all the sides. So that is 1, I've just added 1, plus, well, this side is x, so we've covered that. And this side is, well, we don't really know what this side is. However, we've got x minus 1 here and 2 here, and those sides are parallel. So I could say I've got 2. X minus 1 plus 2 is that distance. Okay, this distance here is x minus 1 plus 2, which is really what? What is that? This is x plus 1, isn't it? Okay, and then we've got this distance here. What is it? What is that distance going to be? X minus 1. Yeah? Okay. All right, so I've got a perimeter of, well, these ones are going to obviously subtract. We've got 2x plus 2 outside, and I've simplified that to x plus 1. Using distributive law, we've got 2x plus 2x is 4x. 2 times 1 is 2. So I've got an expression for perimeter. Now, what about if I was to try and find the area, though? The area is what? Well, first of all, how would you do it if you were trying to find the area? I could break it up into two shapes. All right, good. Now, so we could do it like so. And so that means that we've got the area of rectangle 1 and the area of rectangle 2, if you like. So the area could be rectangle 1 plus rectangle 2, which is equal to 1 times x minus 1 and 2 times x, isn't it? Okay, so which is x minus 1 plus 2x, or is equal to 3x minus 1. Now, find an expression for the perimeter and area of each shape. Now, I've just asked you to do that, but what happens if I was to tell you that over here, what happens if I was to give you an area? Let's have a look at this one over here. Okay. How would I find the perimeter of this shape in terms of x? Well, we've got a rectangle. What's the perimeter of the rectangle? Well, the perimeter of the rectangle, we've got 2 sides. So the perimeter of this side is equal to, we've got x plus 1 times 2. X plus 1 times 2. Plus we've got 2, do we have 2x or 1x? 1x here. And 1x there, don't we? So, yes, we've got plus 2x. And we need to find the curved surface. What can you say to me about that shape? That's what? Quarter. Yep, circumference of a quarter circle. So the circumference of a circle, what's the circumference of a circle in terms of the radius? 2 pi r. Now, what's radius in terms of, we don't have r as such, it's called x in this case. So that is equal to a quarter of a circle times 2 pi r, or 2 pi x. Which is equal to 2x plus 2 plus 2x plus What does that simplify to? 1/4 times 2 pi x. Would you agree that that's pi x on 2?
Yeah.
Yeah? Pi x on 2.
How did you get that? Sorry.
Well, 2, I've just multiplied across. That's the same as that. 4 times 1, 4 on the bottom. 2 on the top. 2 over 4 is a half.
Oh,
Yeah. Okay? All right, so that is equal to 4x plus 2 plus pi x on 2. Now, so far, we're really just finding expressions, algebraic expressions. But what happens if I was to get an expression for the area? Well, an expression for the area, what would that be? Split it up into a rectangle? Yep.
Split it up into like a quarter circle and rectangle.
So what's the area of a quarter circle? Pi r squared on?
Quarter.
4. So pi x squared on 4 is going to give me the area of this guy here. And length times width of a rectangle, x times x plus 1. Okay. Now, how could I simplify this fraction and actually get this, add those two together? What could I do? I've got pi x squared on 4, and I've got plus x outside of x plus 1. What would I do? Yeah.
Expand brackets or just times everything by 4.
Yeah, okay, so I want that over 4, which means that I also have to do that, don't I?
Yeah.
Okay. Now, for the time being, I'm just going to leave it as that, because I wanted to actually go through. So the idea is we can actually then, when we have these algebraic equations, we can simplify them and simplify algebraic and use algebraic fractions, just like we went through last class. So these are the sort of things that we then have to simplify, okay? Now, I'm going to pause the video and I'd like you to have a go at this, please. So have a go at these two questions now. Okay, here we go. So the first step, of course, is... Yeah, that's fine, that's fine. The first step, of course, to do this is we want to change this divide symbol to a times, don't we? It is a divide symbol.
Oh my god.
Okay. So, I've got 3a plus 4, which means that I can do the old flipperoonie. First step, we use an equal sign, meaning that is equivalent. Now, we can only cancel common factors. For example, if this was a 15 here, you can't cancel that because, well, you just simply can't. It's not a common factor. Okay, 15a plus 4 isn't a factor of, doesn't share common factors with minus 15a minus 20. So what I would do though is first of all factorise. So let's factorise the top. And what would be a common factor of...
Minus 5.
Yeah, okay, good. So minus 5, which gives me 3a plus 4. Would you agree? Oh my goodness, look at that. Look at, what does this one say?
Now you've got a
3a plus 4. That's brilliant. Okay. Now we can say that the numerator and the denominator do have common factors, and we can only cancel common factors. That's like a really ugly looking F, isn't it? Did you have a question? Yeah? You sure? You're scared? Don't be scared.
I was just saying, instead of factorising it, could you just know that 3a minus 4 goes into negative 15a minus 20 negative 5 times? Is that wrong?
Well, yeah, but you've got to show your working. You've got to factorise.
Okay.
Because then we can now, the numerator and the denominator both share a factor of 3a plus 4. So we can cancel those. And we've got negative 25 on 15, if you like, or we could do some cancelling this way. 5 goes into 15. That becomes a 1. That becomes a 3, doesn't it? Can I get a show of hands of students that got negative 5 over 3? Okay, about half the class, a bit more, which is good. Fantastic. Next one then. Before we go ahead and do it, and you don't have to necessarily write this down, but what's my lowest common denominator for this fraction? If I'm adding two fractions together, it is 6. Good. Sometimes it helps for you to write that, please. So if you do make a mistake, at least I can see that you recognise that the LCD is 6 if you go ahead and make a mistake. Which means I've got to multiply this fraction by 3 over 3 and this fraction by 2 over 2. That's going to look like this. Please use your brackets though. This is what a lot of you are not doing that. You're going 3 times 2x plus 1 and you're not using your brackets.
Why can't we just go straight to 6x?
Yeah, but what I'm saying is using brackets means that you're going to make less mistakes. Okay, so just trust me on that. All right, so I would hope I've gone straight from there to this line here, this second line. Now I want to use distributive law. 3 times 2x is 6x. 3 times 1 is 3.
I just did that straight away.
Yeah, that's fine. That's perfectly fine.
I don't need to show that.
No, you don't. As long as I can see that you know what you're doing, that's fine. Be careful. Make sure that you remember that there's a negative out the front. So 2x with a negative is minus 2x. Negative, so we'll say positive 2 times negative 2 is negative 4. Negative 4, but with a negative out the front is... So positive negative 2x. If I had a negative out the front, I'm going to put a brackets. So I'm going to say that is negative 2x, positive 4, you could do that over 6, or you could do... Because a negative times a negative is a positive. So you could do it like that, or we could say negative 2x plus 4 over 6. Probably best to do it that way. All right, now, of course, now we have the common denominator. We can add them, yep. So now we can go 4x plus 7. No? Answer's 4x plus 7 on 6. Did we get that?
Yeah.
Huh? Can I please get you to have a go at these questions now? I'd like to see how you go with them, and we'll go through them in about 5 minutes. Away you go. 3, 2, 1. All right. When we're solving for x. Okay, so when it says, so the difference is now, is that we want to find what x is rather than just simplify a fraction. Now, as you can see, you can do it, look, a lot of you do it different ways, okay? But of course, what I'm seeing is I want to get x by itself, so I want to cancel or get rid of this fraction. So first of all, I'm looking at the denominator, and the denominator is a 4. So the inverse operation of divide by 4 is times by 4. And of course, this would be out of balance. If I had a seesaw, if I go ahead and sit myself on there, big 90 kilos worth, okay, it's going to tip the seesaw down, isn't it? The only way that seesaw is going to stay is if I get another Mr. Underwood or equivalent size and sit on the other side. So I have to multiply this side by 4. Now we know that anything divided by itself, that's the whole point of the inverse operation, is we've cancelled out that divide sign. So what are we left with? We're left with x plus 3 is equal to 8. Is that right?
Yeah.
And then I'm going to subtract 3 from both sides, the inverse operation of that 3. X is equal to 5. All right. Now, this one, however, a lot of students remember that when we're... Ooh, Jesus. Okay. All right. Settle down, kids. All right. Now, we've got BODMAS. When we are solving equations, we always need to solve them in reverse. In other words, we need to deal with the addition and subtraction first and get rid of it. So you cannot go ahead and get rid of this fraction. I'm just telling you, you can't. Okay? So this fraction here, we need to leave that, but until we deal with the positive 8, we've got to get rid of that addition and subtraction. So I'm going to subtract 8 from both sides, which leaves me with x plus 3 over 4 is equal to negative 6. Now what I want to do is I have dealt with my addition and subtraction, but remember there's actually technically a brackets here because that's all divided by 4. The brackets is what happens last, but the problem is that it's not in brackets, so that's what's confusing about it. What we need to do now, though, is we need to deal with the division and multiplication. At this stage, means that we can do the inverse operation there. Do that to both sides. Cancels. We have x plus 3 is equal to negative 24. And of course, we want to isolate x by itself. Inverse operation of positive 3 is minus 3. So x is equal to negative 27. Can I have a show of hands of students who got negative 27? Good, good. Okay.
First try.
Now, this last one. I wanted to, let's get out the colours here because this is probably important. You can see here that we've got 2 fractions. Now, this method that I will show you is what we call the cross multiplication method. When I have 2 fractions, I can essentially do this. But why can we do this? Why can we just grab that 4 over there? Well, let's just deal with this in 2 steps first of all. Because if we don't realise what the 2 steps are, we can't do it in 1 step. So I've got a 3 here divided by 3. So on the left, that means, of course, the inverse operation of that is times by 3. Of course, that seesaw's out of balance now. I've got to do it to both sides. Okay. You're just picturing me now on a seesaw now, aren't you? All right. Now, this 4, same thing, but I'm going to do it in a slightly different colour. We're going to multiply the right-hand side by 4 to cancel that out. I have to do the same to the left-hand side. Now, what's going to cancel then? We're going to effectively, this 3 and this 3, well, that's why we did it in the first place, to cancel out that. So the only 3 that's left over is on the right-hand side. And same thing on this side. This 4 and this 4 cancel out. So the only 4 that's left over is this. So as you can see, this is why it's called the cross multiplication method, because the 4 on over here actually does the old switcheroo and goes up there. So the next line is 4 outside of 3x plus 1 is equal to 3 outside of 2 minus x, bless you. 4 times 3x is 12x. 4 times 1 is 4. 3 times 2 is 6. 3 times negative x is negative 3x. Okay, let's have a look at the right-hand side. We've got negative 3x. We can add 3x to both sides. Could be one way of getting x's, all the x's the same side. And I'm left with this. And then I have to subtract 4 from both sides, don't I? I want to subtract 4 from both sides. 15x equals 2. Therefore, x is equal to 2 over 15. Hands up if you've got that one. All right, that's a good portion of the class. It's good to see. All right. Now, before you exit today, I'd like you to have a go at this question here. I'm going to stop this video now, but if you're watching it again, I'd expect you to have a go at this, see if you can do it. So can you please have a go at this now?